VLANs, virtual local area networks, are how you partition one physical switch into multiple logical broadcast domains without buying separate switches for every department or function. Each VLAN is assigned an ID between 1 and 4094, and devices in different VLANs cannot communicate at layer 2 without a router or a layer 3 switch to route between them. Think of a VLAN as a set of invisible walls inside a building. Physically, everyone's in the same open floor plan, but logically, the walls mean the accounting department's broadcast traffic stays in VLAN 10 and never reaches engineering in VLAN 20. Access ports carry traffic for a single VLAN. That's where your end devices plug in. A PC in VLAN 10 connects to an access port. The switch marks incoming frames from that port as belonging to VLAN 10 internally, but the PC itself never sees a VLAN tag. Trunk ports are entirely different. They carry traffic for multiple VLANs between switches, or between a switch and a router, or between a switch and a virtualization hypervisor. To keep the VLAN membership straight as frames travel over a trunk, 802.1Q inserts a 4-byte tag directly into the Ethernet frame header between the source MAC address field and the Ethertype field. That 802.1Q tag has exactly 4 fields you need to know. TPID, Tag Protocol Identifier, is always hex 8100 in hexadecimal, which signals to the receiving device that this is a tagged 802.1Q frame. PCP priority code point is 3 bits used for quality of service prioritization, which tells network devices which traffic to forward first when the link is congested. DEI, drop eligible indicator, is 1 bit used to mark frames that can be dropped during congestion. And the VLAN ID is 12 bits. 12 bits gives you values from 0 to 4095, 4096 possible values, but 0 is reserved to indicate no VLAN, and 4095 is also reserved. So your usable VLAN ID range is 1 through 4094. That 4094 ceiling is a hard architectural limit of 802.1Q. 2 security considerations that are absolutely worth burning into: memory. The native VLAN on a trunk is the VLAN that carries untagged frames. Any traffic that arrives on a trunk without an 802.1Q tag is placed into the native VLAN. The default native VLAN is VLAN 1 on Cisco switches, and you should change it in production environments. VLAN hopping attacks exploit mismatched native VLAN configurations between 2 trunk endpoints to inject traffic into a VLAN the attacker shouldn't be able to reach. And DTP, Dynamic Trunking Protocol, automatically negotiates trunk mode between connected Cisco switches, which sounds convenient but creates an attack vector. Always configure trunk mode explicitly with switch port mode trunk, and disable DTP with switch port negotiate. Here's where things get genuinely interesting for modern data center design. We just established that 802.1Q supports a maximum of 4094 usable VLAN IDs. That 12-bit field is a hard ceiling. For a campus network or a small enterprise, 4094 VLANs is more than enough. But a large multi-tenant data center, the kind a cloud provider or colocation facility runs, might host dozens of enterprise customers, each needing their own isolated layer 2 segments with hundreds of VLANs per customer. You can burn through 4094 segments fast. Enter VXLAN, Virtual Extensible LAN. VXLAN solves the scale problem by taking an entire Ethernet frame, the complete original MAC header payload, and FCS, and encapsulating it inside a UDP packet. That outer UDP packet uses destination port 4789, which IONA has assigned specifically to VXLAN. The UDP packet gets an outer IP header with standard routable IP addresses, and an outer Ethernet frame for the last hop link. This whole wrapped structure travels across a normal IP routed underlay network. Just standard routed layer 3 infrastructure, nothing special required. On the remote side, a device called a VTEP, VXLAN tunnel endpoint, receives the outer UDP packet, strips off the outer Ethernet, IP, UDP, and VXLAN headers, and delivers the original inner Ethernet frame to the destination. From the perspective of the virtual machines or bare metal servers at each end, they appear to be on the same Layer 2 broadcast domain, even though the underlay between them is pure routed Layer 3. That's the power of the overlay concept. The breakthrough that makes VXLAN scale where 802.1Q cannot is the VNI, the VXLAN network identifier. The VNI field is 24 bits wide. 2 to the power of 24 equals 16,777,216 unique segment identifiers. 16 million versus 4,000, that's the jump in scale that VXLAN delivers to multi-tenant environments. Each VNI isolates a separate Layer 2 segment in the overlay, equivalent to a VLAN but without the 4094 ceiling. Cisco deploys VXLAN in 2 primary contexts you need to know. ACI, application-centric infrastructure, uses VXLAN as the overlay fabric between leaf and spine switches, with policy distributed via controller called the APIC. And EVPN-based spine leaf architectures use VXLAN as the overlay with BGP EVPN as the control plane for distributing MAC and IP address reachability information across the fabric. The spine leaf design creates a highly predictable 2-hop path between any 2 leaf switches. Every leaf connects to every spine. For the exam, lock in 3 things. UDP port 4789. The VNI is 24 bits, which gives approximately 16 million. 3 questions on devices, VLANs, and VXLAN. Take a moment to think through each one. Genuinely, before reading my answers, pausing to retrieve from memory is worth more than reading along passively. First question, which device uses a MAC address table to decide where to forward frames? That is the switch. Operating at Layer 2, the switch builds its CAM table by observing which source MAC addresses arrive on which ports, then uses that table to forward frames only to the port where the destination MAC was last seen. Routers use IP routing tables at Layer 3. Don't confuse the two. Switches use MAC tables, routers use IP tables. Second question, how many bits is the VLAN ID field in an 802.1Q tag? And what is the maximum usable VLAN ID? The VLAN ID field is 12 bits. 12 bits gives you a range of 0 to 4095, 4096 possible values. But values 0 and 4095 are reserved, so the maximum usable VLAN ID is 4094. That 4094 ceiling comes up all the time in data center design conversations, and it's exactly why VXLAN was invented. Third question, how many unique segments does a 24-bit VXLAN VNI support? 2 to the power of 24 equals 16,777,216. Roughly 16 million unique segment identifiers. Compare that to 802.1Q's 4094, and you understand immediately why VXLAN is the foundation of every modern multi-tenant data center fabric. If the binary math tripped you up, go back to the VXLAN slide and look at the 24-bit VNI callout. That math is fair game on the exam. Ready?